Good morning, everyone, and welcome to the Enhanced Microalgae webinar. I'm Kostas Edoropoulos. Thank you, Gonzalo, for the kind introduction. I'm a professor at the Department of Chemical Engineering and Analytical Science, the University of Manchester, and I'm API for the project. So what I want to do is welcome you to the webinar, introduce a little bit the project, say a few introductory things about microalgae and their potentials, and also tell you a few things about how the day or the afternoon actually will proceed. Yeah. So, right. If you are here, I guess you are all subscribed to the idea that production of high added value compounds from microalgae is a business sector with immense potential for the coming decades everywhere in the world, but especially in the Atlantic area, which is part of the remit of this project. Enhanced Microalgae has a number of objectives of facilitating development of industrial and business growth in the microalgae sector within the Atlantic regions, and I'll tell you what the Atlantic regions are, although it's kind of obvious. So the main objective is to contribute to the competitiveness of microalgae-based industries in the Atlantic area. What is the Atlantic area, though? So on the right of the screen, you can see a map, and the Atlantic area countries and regions are in blue. The Interreg Atlantic Area Program is a part of the cohesion policy of the European Union, and the idea is to give support to cooperation projects that are transnational, right, for 36 Atlantic regions, which belong to 5 countries: France, Ireland, Portugal, Spain, and UK. And the idea is to contribute to the economic, social, and territorial objectives of cohesion between these countries and this area. The Atlantic Area Program aims to implement solutions to respond to regional challenges in innovation, efficiency of resources, environment and cultural property, and the main goal, of course, is to support development and sustainable growth of these regions. So the Enhanced Microalgae project has a number of full and associate partners. Anfacos Ecopesca from Spain is coordinating the project. We have a number of universities from UK, Portugal, Spain, and France. We have research institutes and companies, of course, from all 5 Atlantic area countries, and our associate partners are all companies. Right, so a brief introduction on microalgae. Again, I'm sure if you are here, most of you would know about this, but it's good to introduce the concept. So algae in general are a wide range of aquatic organisms capable to perform photosynthesis as plants would do, right? And what is photosynthesis? It's the process where sunlight energy is absorbed by the chlorophyll pigment, and then it is used to convert water and CO2 from the atmosphere to make chemical energy, and this chemical energy is used to sustain and to enhance cellular growth. And it's within the grown cells that we find the important components that will produce all our added value chemicals and materials. So microalgae comprise more than 30,000 known photosynthetic microorganisms. However, despite this large range of strains, only few of them to date are used commercially. So the idea is that if you can make the growth of microalgal cells efficient and fast enough, right, you can have access to a wealth of products. And this is the idea that we want to exploit in the project, of course. So here's a schematic of a microalgal cell. take sunlight, carbon, nutrients, and water, of course, to grow. And within the grown cells, we have a number of important components forming there. We have starch, lipids, pigments, protein, vitamins, nucleic acids. So from those components, with the appropriate downstream processing, you can obtain a number of very important chemicals, biofuel, such as bioethanol, biobutanol, biodiesel, aviation fuel. And that comes from the starch and the lipids. From the pigments, you can get nutraceuticals, food colorants, and cosmetics. And from the proteins, vitamins, and nucleic acids, you can get a number of pharmaceuticals, bio-oil, and recombinant proteins. What is very nice about this sustainable biomass is that even the rest of the cell is useful, right? What's left after you process these components. So you can obtain methane and nitrogen from anaerobic digestion, animal or aquaculture feed, or even soil conditioner and other materials. So the whole cell is useful. Okay, so this is a schematic of a microalgal biorefinery where you can take microalgal biomass, you can process it either thermochemically or biochemically, or both actually, to co-produce a number of added value chemicals and materials. As you would have heard, microalgal biorefineries are also called third generation biorefineries. Okay, at this point, it's more a conceptual idea rather than a pragmatic reality. And one of the objectives of the project is to make this a reality, actually, so from concept to reality. Of course, first generation and second generation biorefineries are based on food-based crops or lignocellulosic biomass, which have their own challenges and controversies, of course. So there's a number of important steps from microalgal biomass to high added value products. So there's cultivation, key crucial step, harvesting, and downstream processing. And all these steps have to be done at maximum efficiency in order for the biorefinery to be economically viable and sustainable. And this is very important. Okay, so what is EnhanceMicroAlgae project doing? Through the 8 work packages, we are looking at all the opportunities to enhance the viability of microalgal biorefineries. We are looking into communications, part of which is this webinar, of course, gaps and technical barriers, market research, capitalization, legislation and environmental issues, R&D for added value product applications, which is where session 2 of today's webinar is dedicated, and of course, knowledge transfer, that is very important, always. Okay. So the objective of this webinar, of course, is knowledge transfer and dissemination within the project framework. So this is work package 2, which we're leading. That's why we're hosting the seminar, right? The idea is to disseminate the major outputs of the project, and importantly, the virtual tools that we are developing throughout the project to the microalgal community. So what you'll hear about today, you'll hear a lot about microalgae market trends and applications. You'll hear about project virtual tools that we're developing, which importantly are freely accessible to all, right? And you'll hear about research and development outputs. So you all have the program of today's webinar. We're in session 1 now. There is a break around 1:30, 1:40 for a few minutes. Then session 2 so session 1 is chaired by Gonzalo, who you heard from. Elizabeth is going to chair session 2. There is the end of the session is around 10 minutes past 3. After that, we have two parallel breakout Q&A sessions, one for session 1 and one for session 2. As Gonzalo said in the beginning, the idea is all the questions to the speakers should be done through chat, and then the chair will choose one or two questions to be answered on the spot, and then every other question will be answered by recording. However, in the two Q&A sessions, you'll have the opportunity to talk to the speakers live and get your questions answered on the spot. So please stay for that because it's an important part of the webinar. Login details for the two breakout sessions will be given to you at the break. So, thank you very much for listening. I hope you enjoy the rest of the afternoon. And if you have any questions, please let me know.
Thank you very much, Kostas, for the welcoming talk to the EnhanceMicroAlgae webinar. Yeah, so again, just to make sure the participants are aware of this, put all the questions that you have in the chat box, and we're going to make sure to try and answer all of them. If you have any general questions during the webinar, please also type them in the chat box, and we're going to try to address them privately or generally to all of the participants. So it's time to go on to the first talk of the EnhanceMicroAlgae webinar. This is going to be given by Neha Srivastava. She's from a patent analyst from Mintel, and she's going to be talking to you about the promising future of microalgae, specifically about the market directions and forecast for microalgae products. So welcome, Neha. I give you the room to speak to the attendees. Thank you.
Thanks, Gonzalo, and thanks, Professor Constantinos, for giving the brief about the project you are heading related to microalgae. So today I'm going to discuss about the promising future of microalgae. I'm Neha Srivastava, working as a patent analyst with Mintel, and I have a decade of experience in analyzing the patents, doing the searches related to various life science categories. So during this webinar, we are going to discuss what consumer want and why, what are the different product innovation trend, and what is going on in terms of R&D by different companies and universities in a patent landscape study. So this webinar is mostly focused on the promising future of microalgae in food and drink categories more specifically. So it has been found that microalgae being having the abundance of nutrients as well as protein, it can be a sustainable source of protein. The micronutrients like vitamins, omega fats, prebiotic components can play an important role in combating malnutrition, which is a global issue. And the third part is using microalgae as a clean food color. So we are seeing nowadays there is a lot of buzz around social media, and consumers are interested in using or replacing the artificial colors or artificial additives with the natural ones, and some pigments of some microalgal varieties which are non-toxic in nature and have different colors can be used to replace these ingredients in market, these products which are already in market. So let's get started with what consumer wants and why, because every innovation and every product development is driven by the consumer's interest. In recent years, for health and well-being, consumers are interested in natural ingredients and natural compounds. And if we look at the consumer data, 53% of German consumers and 22% of UK consumers are interested in cooking sauces which are of natural origin. It can be from plant origin or can be from the superfood. So this opens an opportunity for microalgae or algae to enter in food and drink category space. because they are they are of natural origin. The another trend we have seen in among consumers is their interest in free from claims. As I mentioned earlier, the consumers are interested in free products which are free from artificial flavors, artificial colors, and so on. And from the consumer data, we can see 35% of US consumers are interested in the products which are free from artificial flavors. 35% of Chinese consumers are interested in reducing MSG, that is monosodium glutamate, which is generally used as a food flavor. And 31% of US consumers are interested in food and drink free from artificial colors. So we can see there is a lot of inclination of consumer towards the natural things. And this is the reason microalgae entered in the food and drink category domain. And it is most acceptable by the consumers as well. So if we look at different product innovation trend in the market, which is mostly driven by the consumer's requirement, you can see this graph, which is prepared using Mintel's global new product database, where we capture different types of innovative products launched in countries. And you can see there is a slight increase in use of algae in food and drink category. So this graph we have prepared by excluding the use of algae as a carrageenan or agar, because they are mostly used as a bulking or thickening agent in food. So this graph shows that there is an increase in use of algae in food and drink other than their use as a thickener or gelling agent. So let's see what are the different types of algae which are most popular in food and drink category. So as you can see, spirulina is most popular algae or a microalgae which is used in food and drink category, and it is very popular. Apart from that, this other macroalgae varieties like kelp, nori, wakame are also very popular. But yeah, spirulina is the most popular one, and there is another microalgae which is popular is the chlorella. There are some products which are already in market and they use different components of microalgae to provide the functional or futuristic benefits. So for example, green tea is launched in Israel. It is claimed to be rich in extra antioxidants, and they are increasing the antioxidant component in green tea with the help of spirulina. There is a blue colored fruit juice launched in Germany, and this blue color is claimed to be from the spirulina extract, the pigments which are blue colored pigments which are present in spirulina. The richness of protein in microalgae is also being used in food, and there is a porridge launched in Netherlands which contains fibers and proteins from spirulina. So these are some of the products which are already in market. So let's see what is going on in terms of innovation, what different companies are doing, what are the challenges, and how the researchers across the globe are trying to overcome these issues. So first of all, let's see what are the different filing trends in terms of using algae in food and drink. You can see in last 6 years, there is increase in patent filings related to use of algae in food and drink category. And if we look at different jurisdictions where these patents has been granted, we all know that use of algae comes from the Asian origin, and we can see the dominance of Asian countries with the granted patents. So South Korea has majority of granted patents related to this category, followed by China, Japan, US, and France. If we look at the top players in this field with majority of active patents related to algae in food and drink, Corbion Biotech is Corbion, which is a Dutch food and biochemical producer, is leading. Apart from Corbion, the companies like Euglena Corporation, Itsuwa, and Otsubo are also active in this domain. But you can see that apart from these four companies, other top players are mostly the universities and research institutes. So the research and development related to use of microalgae in food and drink is still in process, and maybe in next few years we can see some big brands with using which can use these patented techniques or products in their premium brands. So let's see what is going on in terms of using protein as a using microalgae as a protein source. From the research, it has been found that microalgal protein are superior than plant protein because they contain more amount of essential amino acids required for growth and wellness of human if we compare it with the plant protein. So this makes them superior, and if we and this is the consumer and product data which shows that consumers are interested in better for me and better for planet, and there is an increase in products, mostly the protein rich drink, which claims to have vegetarian, vegan and sustainable protein sources. And we try to identify whether consumers are interested in these type of proteins or not, because ultimately they are the end users. And we found that 36% of US consumers, 40% of Canadian and 38% of French consumers are interested, very much interested in algae based protein consumption. There are different types of patents are getting filed and granted related to microalgae, and the most important part of these proteins are they can be used as a gluten or soy free protein. There are many individuals who are allergic to soy or gluten or other types of proteins, so protein from microalgae can be a boon for these category of individuals, and people don't have to worry about their allergies and other stuffs. And uh, you can see there are, I have listed few of the patents, recent patent filings by Neuber Foods, Zevo Biosciences and Corbion Biotech, which covers the use of microalgal protein in various food and drink category. On the right hand side, you can see a nutritional bar launched in Germany, and it claimed to have a protein from spirulina, and that is the reason it is marketed as a gluten and soy free protein. Um, if but using protein, microalgal protein have few challenges and issues, because microalgae has the fishy pungent odor, and the color of the protein make it unbearable to be used in some protein shakes and other sweet dishes, desserts. So inventors around the world are trying to overcome these issues by by inventing some technologies. It can be pre-harvesting, pro-harvesting or cultivation technologies to overcome these issues. So I'm going to share some of the patent examples in which you can see there are different types of processes getting patented to overcome the unpleasant odor, taste, and unacceptable color profiles of algal protein. So some companies are doing some kind of pre-treatment by delipidating the algal biomass, or doing some acidic treatment while processing the algal biomass to extract protein. There is a PCT publication which also covers a specific cultivation method by which microalgae are cultivated in such a way that it does not have that unpleasant taste or color or uh, odor profile, so that these microalgal protein can be used in wide variety of food. Not only it will not only not restricted to only seasoning or dressings. It can be used in desserts, ice creams and anything where you would like to increase the protein content of the particular product. The another finding from the patent, we identified that there are researchers are trying to identify different types of components from the microalgae that can help in combating the malnutrition issues. And before that, we try to identify whether how consumers are relating algae based ingredients with their food. So we have found that in China, UK, and US, the consumers finding they are relating algae as a health benefiting food ingredient. There are a couple of patents which covers the use, which have found and patented the use of microalgae to produce prebiotics. So, for example, F3 Platform Biologics has a pending patent for method to produce beta glucan from euglena, which is a microalgae, and it can be used for improving the gut health and also improve the immune response, which is nowadays at present is very important because of the COVID-19 pandemic. The another important component of microalgae that can be used as a prebiotic is phycocyanins present in specific variety of algae. These specific phycocyanins plays an important role in improving the gut microflora and thereby improving the gut health. Microalgae is also rich in fatty acids, and it can be an important source for the people who are now into vegetarian or vegan category, since omega fatty acid is required for cognitive health, and it majority of the source of omega fats are of animal origin. So microalgal oil can be a cruelty free free omega fatty acid source, and there are some patents by Condego and Devnesh Nutrition which covers different variety of microalgae that can be used to extract different forms of omega fats, and that can be used in food, drink, even in cosmetics and pharmaceutical industry. You can see there is a on the left hand side I have included one of the product launch in market which claim to have algae based omega 3 in it, and it is required for as a normal nutritional supplement. In today's world, eye health plays an important role because we are 24/7 stuck in front of digital screen, and everyone want to take care of their eyes. And in the similar manner, 72% of Brazilians are interested in supplements to improve eye health. And carotenoids are the major component which plays an important role in eye health, and although these are found in variety of fruits, vegetables and plants, they are present in very minute quantity. So algae has been explored whether it contains carotenoids or not, and it has been found that it contains carotenoids, and there are some patents which covers the improvement of cultivation technique to improve the to improve the production of lutein in that. And in the similar manner, Korea Research Institute has a granted patent which covers a specific microalgae variety which produces high lutein, which have high lutein productivity, and these lutein can be used in variety of food, drinks and health supplements to provide eye health benefit. And actually producing these high amount of lutein by microalgae will also reduce the cost of final end product, because generally these eye health improving or functional health providing products are very costly. So producing high amount of microalgae, high amount of lutein in microalgae can ultimately help in lowering the production cost, and also it can be available for people of different economic background. Algae is also an exciting source of other nutrients like vitamins and minerals, and can be helpful in overcoming the issue related to malnutrition, which is a global issue nowadays. So inventors across the world are identifying different forms or different variety of microalgae that can be used to produce different types of vitamins and nutrients that can be used as a supplement. In Sweden, recently there is a vitamin B supplement launched, and it is claimed that this vitamin B supplement is sourced from spirulina, and it plays an important role in normal brain functioning. The third and most important part, and based on the consumer trend, is move towards the clean eating and clean label trend. So microalgae pigments can be an important ingredient to add into the clean label trend by replacing the artificial or synthetic food colors with these natural pigments. So there are some, if we consider different colors like red, yellow, orange, these are easily available in different variety of fruits and vegetables. But in case of preparing natural blue or green color, it is very difficult. So different inventors are trying to identify the non-toxic pigments from the microalgae and their use in food color, use as a natural blue food color. So there are some products already launched in market. If you can see, Innocent Blue has launched a juice in Ireland which contains blue color from spirulina. There is a there is a smoothie mix launched in Germany which contains the blue color from superfood algae spirulina. And another blue twist is provided in a spoonable yogurt, which is launched in Denmark. It also contains the blue color of spirulina. So in a nutshell, if I have to summarize, our food and drink category is moving to and inclined towards microalgae and algae. And with the recent development in improving the taste, odor, and color profile of microalgae protein, it might disrupt the existing plant protein market because they are having more number of essential amino acids if we compare it with the plant protein. So this is all about the promising future of microalgae in food and drink category. Thank you everyone for listening this, and I'm happy to answer in case of any question.
Okay, thank you very much, Neha, for your presentation. It has been very informative. So yeah, we can see that the microalgae market is moving in the right direction. So we have a couple of questions here from the participants. So one of them from Martina Ferreira, she's asking, is the rise of microalgae new products and patents based mostly on spirulina and chlorella? Or another food species also gaining
No,
interest?
there are other species as well, and right now companies or inventors are exploring those, but I have provided these results specifically because these are the well-known microalgae to everyone. Spirulina and chlorella are very common, so that is the reason I have included it. But apart from these, there are other microalgae which are being explored, and they're used to produce different components which are used in food, drink, and other categories.
Okay, thank you. So one more question. Do you know which microalgae is suitable for making meat analog? I think it refers to products. So is there any patent referring to microalgae meat products?
So there are some, but I don't remember right now. We did a study on meat substitutes and all, but yeah, there are some, but not specific microalgae. They are using mostly the macroalgae to use as a meat substitute, not the microalgae. So maybe they will be using some components, some nutrients from microalgae, but majorly they have focused, in case of meat substitute, they have mostly focused on macroalgae.
Okay, all right,
Yeah.
thank you very much. So we're gonna, just to let the participants know, we are recording all of the questions that you are asking. So we're gonna send these questions to the speakers, and we're gonna try to reply to all of them offline as well, so that you can have the answer and you have the materials. So thank you very much, Neha. The next speaker in this session is Dr. Maria Jose Chapela. She is from Anfaco Secopesca in Spain. She is the project coordinator of the EnhanceMicroAlgae project, and she's going to talk to us about one of the tools, which is the virtual marketplace. Dr. Maria Jose, you can start your presentation.
Thanks, Gonzalo. And also thanks to all the Manchester team for the excellent organization and the excellent work done to organize this webinar. So I'm going to share my screen. So my name is Maria Jose Chapela, and I am researcher in Anfaco Secopesca. So I'm here today representing the coordinating team of the Enhanced Microalgae project. My presentation is about the marketplace. I think this is one of the most promising deliverables of the Enhanced Microalgae project. And first, I'm going to briefly introduce my company, Untitled. Then I'm going to have, I have prepared 2 slides to give you a briefly overview about the project and the partners involved and the work packages. And then I will try to explain what is our aim building this marketplace for the microalgae sector in Europe. So Manzaco Secopesca is a technology center located in the northwest of Spain and is focused in marine and food research. Is strongly rooted in the business sector. Now we have more than 250 associated companies. And also we have more than 65 years providing technological research and development services to companies. Now we are more than 100 researchers working here in Anfaco. So there are 6 research divisions here in Anfaco Secopesca, and 3 of them are involved in the Enhanced Microalgae project. The divisions involved are the Health, Nutrition and Pharma division, the Circular Economy division, and obviously the Aquaculture division. So, what is the global context of the Enhanced Microalgae project? Europe produces around 5% of the world microalgae productions for food and feed. And what are the challenges to increase this production? So we found that we have to solve the technical limitations to increase the productivity. One of the problems is the scaling of the cultures. Also the contribution of the biotechnology to obtain high added value compounds for human and animal nutrition. The European legislation of novel foods is now also a drawback because it's very complex, and also the low demand for microalgae in Europe. These are some of the most important challenges that we have to face. In this sense, we have this Enhanced Microalgae project to try to solve these challenges and to contribute to increase and foster the competitiveness of microalgae-based industries in the Atlantic area through the transfer of technological and economic expertise to the commercial sector. So the project has begun in November 2017, and it will be extended until the end of April of next year. Well, this slide Costas has shown you before before this slide, so I'm not going to show you a lot of. I'm not going to give you a lot of information about this, but these are the full partners and the associated partners of the Enhanced Microalgae project. This is the work packages. We have 8 work packages, including the coordination, the communication, the legislation, research and development application, and capitalization. However, my part of my presentation is about work package 8, knowledge transfer, because the marketplace is a deliverable of this work package. So in the work package 8, we have 4 actions. One of them is building a sustainable marketplace or a technology transfer office. What is the, well, all partners are involved in the marketplace development. Anfaco is responsible of the marketplace construction, but All partners are responsible of feed the marketplace, engage external participants like today with this webinar. Also exploit the marketplace for its own purposes. So all the partners are involved in this action. In general, a marketplace could be defined as a digital equivalent to a shopping center, where many products and services are presented to the general public. What are the advantages of a marketplace? Using marketplaces can make easier the interaction between customers and sellers. So I have included here some examples of some famous marketplaces like eBay, Booking, Amazon. So what are we trying to do here is a virtual platform to exchange services, project ideas, and interest about microalgae in the Atlantic area, including universities, research institutes, companies, involving all actors in the Atlantic area. So the aim of the enhanced marketplace aims are the sustainability of knowledge transfer beyond the end of the project, and also to be a virtual meeting point, including technological offers and needs for all the actors of the microalgae sector in the Atlantic area. The advantages that we offer are that all the information is only in one place with a higher level of traffic. We will have more access to the public and an easy way to find collaborators for projects or for activities regarding microalgae. So to know a little bit more about the marketplace, we have to visit the web of the project. Inside the web of the project, we have this in the menu. We have the marketplace there. So I'm going to show you I'm going to try to show you virtually the marketplace, how it's doing now. I'm going to share this. So this is now we are. This is how it looks the marketplace today. We are still working on it. We are also including all the information from all the partners of the project, but also from other partners. And you see here in the upper part of the screen, you have a small explanation about how it works, the marketplace. Also, you have in the right part of the screen, you can become a member for free. You have to click here in your register, send in all the information of your company or your institution, and then log in. Once you have registered, you can log in. And also the subscription to have all the novelties of the marketplace. If you have to receive your mail all the new offers and requests of the marketplace. If you log in, I am going to show you because I have logged in before. Sorry. Just to show you that I have logged in. So if you log in, you have your profile, your offers and requests. And if you want to add a new offers, you have all the information here, and you can change or modify your profile as much as you want. Also, well, you can see that here is the first part, and then you have all the offers and requests that we have until now. Okay, we are having some offers now. We classify the offers in technology, biomass, food and feed, cosmetics and pharma, vacancy, well, others. So, yes, vacancies is an option that for certain also vacancies in the microalgae field, jobs in the microalgae field. And we are not having requests until now, but we are working on disseminating the marketplace to gain more people joining us. And this is what we are, how it looks until now. And well, I'm going to finish my presentation. So if you have any question or any comment, thank you.
Thank you very much, Maria Jose, for the talk. So I have shared the link to the marketplace in the chat box so that people can see it and start to look at all of the options. So it's very useful, as you were saying, to find services and offers from microalgae companies and institutions. I think also especially important for vacancies that people are looking for jobs. So one question regarding the marketplace. So the project, as we have said before, is focusing on companies and institutions from the Atlantic area. But this marketplace obviously is open to the public. So is it okay for companies from outside the Atlantic area to subscribe, to use the marketplace?
Is this a question for me? Yeah.
Yeah. Just one quick question.
This is a question. We are always discussing this with our officer, with Tanya, because well, we think that to give this the impact that a high impact, we need to include companies from outside the Atlantic area. However, until now, she has said to us that it's only for companies of the Atlantic area. Okay, but we're working on it. We are trying to include at least requests from outside the Atlantic area. At least requests, and then if it is possible, offers too. But until now, it's not possible. It's something that we are discussing with Tanya, but she's not very fan of it because the financial support of the marketplace is to give support to the companies of the Atlantic area. So it's not easy for her to tell us, okay, include any company, but we are trying and discussing this because we think it's very important to gain impact.
Yeah. Okay. Yeah. Thank you very much. I just thought that it was good to disseminate this to the public, and I'm sure this is going to be addressed also in the next talk, which is going to be by Dr. Laurent Picot from University of La Rochelle. So we have just shown you the Enhanced Microalgae Marketplace. So Dr. Laurent is going to show you another tool of the project, which is the Stakeholder Database. So Dr. Laurent is here already. So please, Laurent, you can start your presentation any moment now. Dr. Laurent, we can see your presentation, but we cannot hear you yet.
We can't hear you, Laurent. We can't hear you.
Yeah, we can see your presentation, Dr. Laurent, but we cannot hear you yet. If you're having an issue, if you're okay with this, what we can do, while you solve it, maybe we can just swap the presentation so we can move with Claudio. If you're okay with it, I'm not sure if you can solve this.
Yeah, I'm all right if you want.
Okay, yeah. So, well, so Lorenzo, we can show your presentation after Claudio. Hopefully we can solve the issue by then. So what we're going to do, as I said, so we're going to see.
Can you hear now?
Yeah, we can hear you. Yeah.
No.
Perhaps, Laurent, if you switch off your video.
Can you hear me?
Yes.
Yeah, we can hear you.
Can you hear me now?
Yes, yeah, we can hear you. So we can see your screen.
Can you hear me?
Go ahead. Yeah, we can hear you and we can see your
screen.
I'm
going to show. So we are La Rochelle University partners of the project, and my name is Dr. Laurent Picot, and I'm Work Package 4 leader. I don't know if you can hear me. I cannot hear you.
Yes, we can hear you. Well, Laurent, we can hear you. We can hear you, Laurent.
So the idea was to develop a microalgae stakeholder database for the European Atlantic area. So it was part of a work package 4, which is called Gaps and Barriers. And the idea was to create an open access, visual, dynamic, and updatable database to easily identify stakeholders and experts from research centers to commercial chains. And using this database, we can characterize expertise, country and regional distribution of microalgae stakeholders to perform an analytical review of the sector. And also we can use this database to identify gaps and potential for research, development, cooperation, and opportunity. So to build this database, it was a collective work, and so La Rochelle University led the project. One doctoral fellowship was recruited to be involved in the project, Dr. Judith Rumin, and all the EnhanceMicroAlgae partners have contributed to build the database by helping to collect national information to build the database. So we have built 2 tools to easily identify key players of the microalgae sector. So the first one is a stakeholder map that can be freely accessible from the EnhanceMicroAlgae website. And we built this map using Google Maps, My Maps. And this map provides name, localization, activity, website, contact, markets, skills, and also the nature of the stakeholder, if it's a private company or a public. And the second tool is an Excel table that can be downloaded from the website. This Excel table can be updated too, and it contains a selection drop-down menu to get advanced information on the microalgae stakeholders. So now I'm going to switch to the EnhanceMicroAlgae website to show you how to use and the information that you can get from these tools. So I'm going to share screen. Okay. And probably this one. Okay. So I don't know if you can see the website now.
So we cannot see it.
So this is the EnhanceMicroAlgae website, and on this website you have a link to the Stakeholder Database that you can use here, and on this link you can access a map, which is that you can focus on this map, and when you go on a link on a partner, then you will find the information about the company or about the university that is involved in microalgae research. So here you find the name of the company or the name of the university. You have also the website of the company, and you have the activity of the company, so you can see what the company or university is involved in, and you can get all this information for all the Atlantic area. For example,
Laurent, sorry, we cannot see what you're
it's
showing.
a company, Baggy Power, located in Porto Santo, and then you have access directly to the website, and you see the activity of the company. So it's involved in feed, development of food from microalgae, nutraceutics, biotechnology.
Okay, hello everyone. So sorry, I think there is an issue right now with Laurent's screen, but so this is a stakeholder database that he wants to show to you. We have just shared the link in the screen. So as you can see, there is a map with the companies and institutions about microalgae companies. So you can go to the website, and then there is an Excel link where you can actually see the database of all the companies. So this is updated over time. I think the problem with Laurent is that he cannot hear us at the moment. So even though we are telling him, I think he's not aware of the issue. We're gonna try and chat to him offline to see if he can solve the problem. But yeah, so I have just shared the link to the stakeholders database so that you can have a look at the page. So Claudio, I'm not sure if you are there, so because there's an issue with Laurent, so I don't think we can see what he wants to share with us.
Yes, I'm here. So
yeah, if you could just start your presentation while we solve the problem with Laurent, because I think.
Okay. Yes. I'm going to start sharing my screen.
Mm-hmm.
All right. Wait. All right. I hope you can see my screen now.
Yeah, we can. Yes.
All right. Cool. There we are. And wait.
Okay, so while you're setting up, so well, because it wasn't the time for you, but well, just to introduce you briefly, so the next speaker is Dr. Claudio Fuentes Gruneval from Swansea University. He's leading Work Package 7 of the EnhanceMicroAlgae project, which is related to research and development. And he's going to talk to us about a tool that is also on the website, which is the Decision Support Toolbook. So yeah, go ahead, Claudio. Thank you.
Okay, all right. Okay, hopefully you can see now my screen. All right, I'm going to try to move this one here. All right, so basically, well, thanks to all the audience to come to this webinar. It's really glad to have more than 80 people here. I'm really glad of that. And the idea now is to show you one of the tools that we have in our EnhanceMicroAlgae project. All right, this is part of the Work Package 7. All right, Work Package 7 is basically research and development. And this DST tool, decision support tool, is part of the action 2. Right. So basically, you will see that in order to create this tool, the idea is to beforehand to run different experiments in a real and a higher scale. We are talking about at least pilot scale of 1,000 liter or more culture in different systems like PBRs or ponds, and as well using different kind of species, you know, standard commercial species, because one of the aim of this project is to validate all those numbers that we have from those species, the common ones like Nanochloropsis, Chlorella, and Spirulina, but also the idea is try to produce new biomass from new strain. Like we have been doing a lot of work with cyanobacteria, and we have been producing nostoc and other type of cyanobacteria that are rich in different valuable compounds. Right, so the idea is to collect all this data and basically try, test, and validate the DST tool. Right, so all the growth parameters, as you can see here, growth parameter will be used to inform development of a DST tool enhanced by biochemical characterization to inform production rate estimate and ensure consistency. All right, so this DST tool, it was created, designed, and launched by a former professor of Swansea University, Professor Kevin Fring. He worked at the interface of experimental plankton ecophysiology and simulation modeling. Right, he's a well-recognized top leader in microalgae world. You know, in microalgae field, he had more than 170 papers in microalgae, and Kevin was the man who actually wrote the book, and you will see later on, or you can download later on the book from our website. I'm going to show you how to do that. All right, but what and why DST? This is a key question that we need to try to answer. Okay, so basically what DST is a computer-based simulation description to experiment with. So this is the main reason of a simulation or a DST tool, all right? So it's a simulation description. Why? Basically, because real algal growth is slow and expensive to study, right? Specifically for small spin-out companies, or for instance, a small research institution, university, that they don't have all the facilities in order to set different microalgae experiment. DST tool could be a really good tool in order to try to identify new strain or how they're going to behave in different kind of environmental parameter, right, and production parameter. Okay, normally when you are running proper standard experiment using real microalgae, so you have sometimes a lot of mistake, and those mistakes are costly, right? It costs money and time, basically, right? Simulation are cheap, so and it's free in this case, because we are uploading this ebook and DST tool, so you can download to your computer and you can play with it, which is really good, and you will see that it's really fast too, and that is a really good output of this DST. With this tool, you are able to identify bad options quickly. All right, so you can try, for instance, a different light regime. You will see straight away if the algae is able to grow at that light regime. Okay, so that is why it's really useful, this DST tool. All right, and concentrate the effort on better options. So as long as you are testing all your microalgae strain, then you will realize which one is the best option according to the parameter that you are feeding into the DST tool. All right. So I'm basically the best option for exploration with a real system. Okay, so then if we're gonna answer the question why, and you will see why in this screen. Okay, so basically, this is the real life when you want to do an experiment and try to grow or scale up an algae. Okay? In this case, this is Nanochloropsis, and as you can see here, this is the way that we scale up Nanochloropsis or any other kind of strain. So basically, we go for a tiny little volume, less than 200 ml, then we go for a liter, then we go for 20-liter carboys, then we go for 80-liter bag, and finally, we are in our biofence, which is 100-liter each one, right? But as you can imagine, each of these steps take at least in Nanochloropsis 7 days. So nearly 2 months to reach this stage, all right? And when you are at this stage, you can follow or you can collect all the data regarding the growth rate, for instance, in this case, using optical density and the nitrate octane, and then you can, as soon as you harvest, you have to process the biomass in order to know what is the lipid content, for instance, all right? So this is a really expensive and slow way to do this. And that is why DST is a good option, and I would encourage you to all of you to try and use this DST tool that we are providing for free, right, in this Enhanced Microalgae project. All right, what does the DST comprise? All right, so basically you will see and you will download a free ebook on aspect of algae physiology and culture with an introduction to DST. I have to say that Kevin have done a really great work in this book, and actually I would encourage you to, I have some echo, some background, sorry. If you can mute yours. All right, that's right. Okay, so basically I was saying that Kevin have done a really good work in this book, because it's not just about the DST. You will realize that it's a comprehensive understanding of microalgae world, or microalgae culture, microalgae physiology, even all the part of the process in order to produce algae. So you will see the upstream, the culture phase, and also the downstream processing. So it's a really comprehensive book, and it's really informative. And I would encourage you, to all of you, to read this book before starting to play with the DST, right? Then you will see in there that is an introduction for those who wish it, of course, on simulation modeling, all right? And then, of course, you will have a free simulation model for end user, for all kind of end user, and used to aid commercial facing decision in the growth of microalgae. And this is how it looks, right? We will play at the end of this talk. We will play this DST or this model. Okay, so basically, is that how it works? So if you go, actually, you can go now to our website, EnhanceMicroAlgae EU, right? And in there, you will see that we got the decision support tool in the task bar at the top of the web page, all right? When you do a click in there, straight away, you will go to the decision support tool subpage, basically, and over there, you will see this, okay? So basically, you would be able to download the DST ebook from this clicking here, all right, in this part. And as well, the idea is doing step by step. So first, download the ebook, try to read it, and then straight away you can download the free software version. This is free for 6 months, so it's enough time to play and basically to test your own strain. All right, as soon as you click in this PowerSync software download, you will see this web page. All right, so I have divided here the DST book, which is this one, is 63 pages. I have to say that this is a live book, all right? So Kevin has been uploading this ebook step by step, so it's gonna be finished by the end of this summer. So then the final version will be at the end of this summer. But anyway, you can start reading now. All right, and basically when when you read the book, then when you click in order to download the software, you will see this web page, and you can download from here. So either if you have a Windows 10, because it just work in Microsoft Office software, and basically if you have Windows 10 installed in your computer, you can download the 64 bits version, or if you have a older version of Microsoft Office, you can download it at 32 bits, right? These are the two options. Okay, so and then basically when you install, you will see straight away that there is a PDF file in there, and you open that PDF file and you will see this screen. Right, this is the screen that you will see, and I'm going to start to explain you this, and we are going to start now to playing this DST or this model. Okay, so now hopefully can you see my screen? Yes, I understand that you can see my screen now. I'm going to move this one a bit here. Okay. Okay, guys, so basically, as you can imagine, in a DST or in a model, we need to feed the model. We have validated this model with real data from our previous experiments. So basically, we run this model, feeding this with raw data from our pilot scale experiment, all right? So that is why it's been validated, this model, and you will see that it's worked very, very well. Of course, there are some constant that you have to fit in there, all right? And then you will get some, basically you will get some result of it. So just to let you know that, for instance, we got here the reactor volume, okay? So this is have been made in order to get a real, at least pilot scale volumes. That is why the minimum volume that you will see here is 500 liter, right? And then we go for 1,000 liter a ton, and then 10 tons. All right, so we have a background dilution, all right, and then we have 3 growth rate. This is the maximum growth rate, all right? This is not the average, okay? So this is the maximum growth rate, and that is why there is 3 options in here. The minimum of the maximum, sorry, the growth rate is 0.35. For instance, a standard microalgae like Porphyridium purpureum, its maximum growth rate in Porphyridium is around 0.35. Actually, its average is around 0.17, 0.20. That is the average of Porphyridium purpureum. All right, 0.69 is a standard maximum growth rate, for instance, for chlorella or for Nanochloropsis, which their standard average growth rate is around 0.30, 0.33, something like that. And 139 is you can reach this maximum growth rate in those cyanobacteria, for instance, like spirulina. Okay, then you have the optical depth, all right? Optical depth is basically the light pathway, all right? So basically, for instance, 10 centimeter bore here is basically the size of a tube, of the standard tube. Normally, standard tube in PBR are 32 millimeter, 63 millimeter, or 65, and 110. So this is basically standard PBR, and then you have pond. Small bore is for really a small, tiny flask, okay? And then you have the harvest frequency. This always depending of the growth rate, but normally most of the species, the lower species, you can harvest every 10 days. The medium one you can harvest every 5 days, and the small one every 2 days. Then you have the light intensity, all right, which is 200, 500, and 2100, which is basically, let's say 200 is the standard UK weather or UK light, all right, higher latitude, 52 degrees latitude. 500, I would say, is in the middle of France, something like that. And 2000 is, I would say, the average, or should be around that average in southern Spain or near the equator, all right? And then you have the harvest proportion from 25 to 95, and different, in this case, ammonium concentration, all right? Okay, so what you have to do first, you have to clean all this. And in order to do that, you have to press in here, all right? As you can see, now is properly cleaning here, all right? And we're gonna play. So what we're gonna do, we're gonna use a standard pilot PBR. We're gonna use 1 cubic meter, it's going to be 1,000 liter culture. It's not going to be dilution, so we are not going to have evaporation. We are going to use Porphyridium purpureum, for instance, maximum growth rate of 0.35. This is going to be a PBR with a pathway light pathway of 10 centimeter, right? We're going to do a harvest frequency of 5 days, and we're going to run this one in Wales. And our harvest proportion is gonna be, I would say, 50%. Okay, and we're gonna run full nitrogen, which is normally F2 N source in F2 cases around 880 micromole of nitrate. In this case, we're gonna use the maximum of 1,000 micromole of nitrogen, but in this case, the nitrogen source is ammonia. All right, so when we choose all of these, we can play, all right, we can play it in here, and you will see how this, how it looks, all right? So we are playing here, okay? And there we are, all right? So less than a minute, you have your numbers in here. As you can see here, and if you go at the bottom of this, okay, it says the high NC algae, which is this one, indicate a high protein content because it's higher than 0.15. So we would expect that our Porphyridium have a good amount of protein, which is basically, in the case of Porphyridium, we can, for instance, harvest the phycoerythrin, which is a water-soluble protein. It's really expensive and high-value metabolite. All right, so as you can see here, we have an average, I would say, around 60 grams of biomass per cubic meter, all right? And you can see that this is increasing all the time. So this is if we go back, all right, and we do exactly the same simulation, all right, 1 cubic meter, no background dilution, 0.35, PBR of 10, harvest frequency of 5 every 5 days, you know, 50%. But in this case, we go down to Spain with a higher light intensity throughout the whole year, all right? And with a higher ammonium content, you will see the main difference in here, okay? And you will see how it's increasing and increasing, all right? The amount of, we have now an average of 80 to 100 grams of biomass in terms of carbons, right? So you can see here, and then we have, I would say, a bit lower amount of nitrogen inside the cell, so shouldn't be so high, the protein content in this one, all right? So this is the way that you can play. For instance, we can play as well, trying to mimic, all right, what is going to happen with a pond, all right? Pond normally is a really high volume, so we're going to choose a reactor volume of 10 cubic meter, all right, 10,000 liter. In this case, yes, we have a background dilution, which is the evaporation that we have, because it's an open system. So let's say that we have a 5% of evaporation in a daily basis. We're going to grow a really good one, which is spirulina or nostoc, where they have maximum growth rate of 139. Normal standard growth rate is around 0.40, 0.50, something like that. And then yes, the optical depth of a pond, which is normally between 20 centimeter to 30 centimeter in depth, right? And then basically we're going to harvest again every in this case, because it's a high growth rate strain, we're going to harvest the frequency every 2 days. All right, we're going to start in Wales, all right, and it's going to be a 50% of the harvest proportion, all right, and with a minimum amount, in this case, of ammonium concentration. And we will see what happened in here, all right. As you can see now, we are obtaining, right, a way better amount of biomass, because we have a higher volume in here, you know, so the average is around 140 in this case for each cubic meter, right? But the production is not that big, right? And a key thing in here, our content of nitrogen inside the algae is low, right? If this green light should be the complete or full of nitrogen, but in this case it is a lower concentration inside our cell. This is not good for us if we want to grow spirulina, because for instance, one of the products from spirulina, as we have heard before in other presentation, is phycocyanin. Phycocyanin is a water soluble protein too. And what we want a higher content of nitrogen, a higher content of phycocyanin in order to get the maximum amount of phycocyanin, all right? So that is why what they are missing here, basically ammonium, they are missing nitrogen. And perhaps you will see a big difference on this when we change from Wales to near the equator, let's say 10 to 15 degrees from the equator, when we have a higher light incidence, and we will have full ammonia in there. So let's gonna play again. This is the final one. So we're gonna have a reactor volume of 10 cubic meter. We have a background dilution of 5% in a daily basis, a high-speed algae like spirulina or any kind of cyanobacteria, most of them. We're going to have a ponds, the harvest frequency, it will be every 5 days, but we will have a higher solar irradiation, and we will have the same 50% of higher proportion, and with a high amount of ammonium in this case. All right, we play again, and you will see that straight away we go really up in this scale, and you will see this massive difference. All right, so we got nearly a kilogram of algae for cubic meter. All right, and then this is as well the average of that, and you will see here this is good for us if we want to produce phycocyanin. Why? Because our content, nitrogen content inside the cell, which is basically nitrogen is protein. Of course, there are other like a DNA and other membranes that they use nitrogen as well, but it's mainly protein, right? To build the cell basically. And as you can see here, this content is over 0.15, which is really good. And you can imagine that this content of phycocyanin, I would say that will be minimum 7 to 10% of the body weight. Okay, guys, so this is the DST tool. I hope you have enjoyed this presentation. If you have questions, all right, or if you have any kind of suggestion for this as well, please, you can contact me as a PI of this work package. This is my email. Or if you have a specific question or problem related to the DST tool, please contact the author, Professor Kevin Flynn, and this is his email. All right, and please, if you can use this tool, I'm pretty sure that you will enjoy. Okay, thank you very much for your attention.
Thank you very much, Claudio, for the presentation and to show the DST book page. So it's very useful and informative. So we have a couple of questions from the participants. I'm going to ask you one because I think most of them can be grouped into a single one. So they are asking if we can identify algae in this DST tool, like how many species are available in the tool, and is it specific to a particular strain or common for a microalgae? So I think that what they want to know is whether they can identify microalgae species in this tool or if it's global.
Yes, so this tool is not to in order to identify, right? It's not to identify one algae. This tool allow you to use your own data. Let's say that you are working in a small startup company, all right, and you went to the field and you isolate one algae, all right, and then you run or you grew up that algae for I would say 2 or 3 months with several experiments, and you already know, roughly speaking, you know what is the growth rate, you know what is the size of your PBR, you know the light pathway, you know the amount of ammonia that you have been using or end source, all right, and then you can fit all that information in this DST tool, in this model, and play. Why? Because then you can play with a different concentration, different light intensity, different kind of pathway, light pathway. All right. So and then you will see straight away how it will behave, this new algae, new strain. All right. So it's mainly for that. It's to save you time and money testing this new strain or standard commercial strain in a different kind of with different parameters. For instance, if you are a massive company, all right, and now you will start operation near the equator, and you have your own strain that is growing at latitude 42, right, and you want to know, all right, how it's going to behave near the equator with a high irradiance, with a high amount of ammonia that we will have. We are not gonna grow in PBR, we're gonna grow in ponds. So how it's gonna behave? So then you fit the model and you will see, you will realize how its work is. Okay, so this is the main objective of this DST tool. I would like to highlight just to all of you, because this is a living document, is a living model. Actually, Kevin is working hard in order to release the final version of this, and it's a good, really good news that we will include mixotrophic and heterotrophic growth. All right, so then you can play with different carbon source, organic carbon source, and this so it will be a wider impact, because it's not just going to be for autotrophic, it's going to be as well for mixotrophic and heterotrophic cultures.
Okay, yeah, thank you very much. That's very good, because I was going to ask you that as well, if the model could be used to reproduce mixotrophic conditions or heterotrophic conditions. Just one final question, if you can answer very quickly. Probably the model predictions are like mean values, but do you have an idea if there is like an associated error to the predictions of the model?
Yes, it's always is a associated error, because remember that the physiology of the algae and the whole system contain the algae, you know, the PBR, there are so many variables that you never can handle all of them. Right, so basically you can imagine that, for instance, just in the cell you have the dissolving inorganic nitrogen, dissolving inorganic carbon, you know, you have all the enzymes, and then you have the abiotic parameter in the system. So basically you have the pH, the temperature, the light, you have the system itself, the light path, the pump. So there are several different multi-parameters. Of course, we have an error on that, but I would say that we have been minimized that error, because we have been validating this tool using our own raw data, and we have been growing several species. We have tested with nanochlorosis, with chlorella, with Phaeodactylum. We have used Porphyridium. We have used as well nostoc. We have used spirulina. So we have tested, and it's quite I would say it's quite a powerful tool. All right, and shouldn't be a massive error, I would say.
Okay. Thank you very much for answering the questions.
Okay, so, thank you.
Yeah, thank you very much. So Dr. Claudio will be available at the end of the webinar to answer.
All right, thank you very much to everyone. And basically I will reply to your question in the chat box, or later on I would say Gonzalo is gonna release the QA questionnaire, and we can reply your question. Thank you very much.
Yeah, sure. Thank you very much. So we have spoken with Dr. Lorenzo. He's going to present again in the second session, if you've seen the schedule. So he will briefly introduce again the stakeholder database, because you know that we have a bit of an issue with the screen. So what we're going to do is we're going to move on quickly to the final presentation of the first session, which is about the microalgae strain catalog. So myself and my colleague Elizabeth Bermejo, we're both from the University of Manchester. We're going to talk about this. So here is the presentation. So as you've seen during the first session, we have been showing you some tools that we have created as part of the EnhanceMicroAlgae project. So this last one, it's the strain catalog. The authors of this document are myself, Elizabeth, but also Dr. John Pittman and Professor Costas, who spoke at the very beginning. So a bit of story of the microalgae strain catalog. So there are different work packages associated with the project. Work package 7 deals with knowledge, research, and development. And the goal of this work package is to provide small and medium enterprises with protocols for the reliable pool growth of microalgae of contrasting types to yield protein-rich or carbohydrate, lipid-rich biomass. So how can we do this? Well, one of the actions of work package 7, specifically action 1, refers to publicly accessible microalgae screening. And the objective of this is to build an online database containing information about microalgae strains of potential interest for commercial applications. So we know that there are numerous microalgae species and strains. So what we want to do with this is to compile them all into a single document, at least the ones that have commercial applications. So you can see here, for example, some of the major biomolecules that are found within microalgae, such as polysaccharides, proteins, lipids, bioactive compounds. So all of these compounds, they have obviously different applications. So for example, human nutrition, functional food, aquaculture, they can be used as feed. So when one starts to work with microalgae, or if companies want to enter this sector, they need to be aware of what is the potential use of all of these species. So what we did is we reviewed several articles and information from the open literature and compiled them all into a single document, which you will be able to find online in the EnhanceMicroAlgae website within the publication page. So we have also included some of the journal publications of the project. So far, we have had 2 editions of the strain catalog. We plan on updating the document until the end of the project, but you can find the latest edition if you go to the website. So what will you find inside the catalog? Well, you'll see a list of the species that we have included. Some of them are, for example, Arthrospira platensis, Chlorella vulgaris, Hematococcus pluvialis. And when you go to the page that is specifically for each of these species, you will initially find a photograph with a brief description of the microalgae so that you can have an idea of the morphology of the cell and what it's used for. And then this will be followed by a table that includes the cultivation characteristics of the microalgae, including different culture media, temperature and light conditions, and also important the biomass productivity and the yields. There will also be a table that has the biomass characteristics, particularly relevant for the biomass composition, such as whether it has lipids, carbohydrates, proteins, the elemental composition, but also the profile of pigments and fatty acids, because these components are very useful for applications such as biofuels production or also the production of nutraceuticals and pharmaceuticals. So this structure is followed throughout the document for all of the species that we're including. Just to name a few, we have included, for example, Arthrospira platensis and Chlorella vulgaris. Arthrospira platensis, which is also known or previously known as spirulina, is rich in proteins and pigments, and the areas of application are food and nutritional supplement. Chlorella vulgaris, which is a very robust strain that can grow very easily, and it can grow like in mass culture. It has applications also for food, as nutritional supplement for feed, for biofuels, because of the high levels of lipids and also carbohydrates. We have also included Tunaliella salina, Hematococcus pluvialis. Hematococcus pluvialis in particular, some of you might know that it's considered as the best natural source of astaxanthin, and it's used already commercially by some companies. The uses of Hematococcus include food, nutritional supplement, aquaculture, cosmetics, and we also have Monochloroxis oculata, which has chemical composition rich in protein and lipids. So you will find all of these microalgae species all into a single document, which is what we wanted to achieve, to make it easy for researchers and people from industry to be able to just use the document and get the information that they need, although it's obviously under construction. So we have released now the second edition. So my colleague Elizabeth will continue with this presentation. Elizabeth, we cannot hear you. Elizabeth? Okay, it seems
now.
Yeah, now.
I'm sorry.
Don't worry.
I didn't have the option. Could you share with me the screen again, Gonzalo?
Yeah, now it's ready.
But I cannot see the presentation.
We can see it all, so you just need to continue.
No, but I cannot see the presentation, Gonzalo. No. Okay, yeah. Okay, I'm sorry for that. Now I will continue talking about the second edition of the catalog, which we decided to prepare as an update of the first one, and also to increase the number of microalgae with huge potential for commercial applications. So after a new literature review, finally we decided to select and include 10 more strains. Among these microalgae, we can find Isochrysis galvana and Porphyridium purpureum. Isochrysis is a marine microalgae quite interesting for the aquaculture industry due to its good nutritive characteristics, especially in relation to its polyunsaturated fatty acids, rich in omega-3 fatty acids. And in the case of Porphyridium, it presents high potential to produce long-chain polyunsaturated fatty acids and also isopolysaccharides, which are excellent feedstocks for food, nutraceuticals, and pharmaceuticals. Other microalgae that were included in this second edition were Rhodomonas and Esenedesmus obliquus. Rhodomonas is considered a relevant source of omega-3 fatty acids such as EPA and DHA, presenting in this way an important role in the aquaculture sector. And Esenedesmus is a freshwater microalgae widely used as a lipid producer, being its main areas of applications in aquaculture, human nutrition, and also as a source of energy. The catalog also includes the recipes of the main culture media in which these microalgae can be grown, and it presents a list of the main microalgae culture collections in which they can be found. To finish, say that a third edition has been planned to be released by the end of this year, in which the information of the current microalgae strains will be expanded and more microalgae will be added. And always that it's possible, the strains included in this third edition will be linked with the companies or microalgae services listed in the EnhanceMicroAlgae Stakeholder Database, and also with the virtual marketplace. And well, don't forget to connect with us on social media. We are on Facebook, LinkedIn, Twitter, and Instagram. And thank you for your attention. If you have any questions.
Okay, thank you, Elizabeth. So we have shown you the microalgae strain catalog. We're looking to see if there are some questions regarding the catalog. I think some of you have been asking if you're gonna have the materials available So yes, well, first of all, we are recording the webinar, so we'll make it available later in the website. And we're gonna try and send all of the material that we have presented to you, as well as questions and answers that maybe we cannot address here because of the time. So we're gonna build a document and we're gonna send it to you. So yeah, just remember to keep typing in your questions in the chat box. So yeah, I think that's it for the first session. So we're gonna have a small break, and then we're gonna continue with the second session in about 10 minutes. We're running a bit late because of the issues that we had with one of the presentations. But if you all can come back at 2 p.m. British Standard Time, we're gonna continue with the talks that will be featured in the second session. So thank you for staying with us. And yeah, you can use this break to maybe prepare yourself a cup of tea, just to relax for a bit, and we'll continue in about 10 minutes. Thank you.
Or write directly to Emma, so she will be able to answer them. And now we can move on to the next talk, which is going to be given by Marta Viña, who is a research fellow in the International Iberian Nanotechnology Laboratory in Portugal. And she's going to talk about applications of microalgae in food. So Marta, when you want, you can start your presentation.
Hello, everyone. Can you see my screen?
Yeah.
Yeah, okay. So good afternoon, everyone. As Elizabeth just said, my name is Marta. I'm a research fellow at the Food Processing Research Group at INL in Portugal. And today I'm going to talk about a little more specific than just in food applications. I'm going to talk about microalgae encapsulation for food applications. So the presentation is going to be divided in 4 topics. First, I'm going to give a brief introduction about microalgae. Then I'm going to talk about the challenges of incorporating microalgae into products, followed then by how encapsulation can be a tool to overcome those challenges. And lastly, I'm going to give a practical example. It's just a few results of a paper that I have published in the beginning of the year that shows how encapsulation can be beneficial for microalgae compounds. So as it was already said here during this webinar, microalgae are an heterogeneous photosynthetic microorganisms group that has a vast assortment in their biochemical composition. Here just some of the groups because they have a very interesting nutritional profile. And of course, the proportion of these groups change among the species. However, then when microalgae are exposed to certain stress factors, such as this one, the composition, the initial composition can change drastically. And then they are able to synthesize and metabolize highly valuable substances with industrial applications and healthy benefits. Here is just a compilation of the main microalgae species, the main study one, if you see in the literature, its respective metabolites and its biological activities. These 4 species or group of species are the main one studies for food applications, and its metabolites have been related to several biological activities such as anti-tumor, antioxidant, anti-inflammatory, among others. So the interest in microalgae has been growing in the last decades, mostly because of the growing trend towards the using natural ingredients. This is then stimulated by the consumer safety, environmental sustainability, and regulatory issues that are related to the introduction of chemical or synthetic food additives in the human nutrition. Associated to that, microalgae are then a rich source of high-value compounds, of food-grade compounds, with the possibility of manipulating cultivation parameters to obtain a specific bioactive of interest. Therefore, microalgae is a very interesting approach in the development of healthier, functional, and sustainable products. Microalgae can be applied into products in 3 different ways. The first one is the interest could be the commodity as biofuel. The second one is the incorporation of the whole cell as the biomass to increase the nutritional content of food products. And the third option then will be to incorporate the purified compound. However, purified compound, they are normally very unstable. They are inside of the cell, and once they are extracted from the cell wall, they become exposed to several factors. That could be an oxidative factor that leads to degradation, such as high temperature, extreme pH, moisture, high light. And this consequently could lead to an unpleasant taste and of odors that can affect the sensorial characteristic and the consumer acceptability over a product. Moreover, these purified products, many times they have low bioavailability and poor water solubility. So these compounds, the absorption of these compounds can be hindered by the gastrointestinal condition because the pH of the stomach is very acid. So it can be degraded during this process. And also during the product development, if we're going to incorporate a bioactive that has a different polarity of the food matrix, it can be a challenge. In this context, encapsulation that is a strategy that has been used in different areas to overcome challenges like that. What is encapsulation then? It may be defined as a process in which a substance, an active agent, is entrapped or coated by a carrier material in order to form a particulate system. The substance, the active agent, can be in the solid, liquid, or the gaseous state, and it can be classified according to the size as nanoparticle or microparticle. Here we have a representation of a reservoir system of this particulate system, where the active agent is the core, and it is then surrounded by a layer of the carrier material. But the activation could also be uniformly distributed to this carrier material, and then will be a matrix system. The activation could be of a lipophilic or hydrophilic nature, and the coating material for food application must have a food grade status, and it could be of a bio-based orange or synthetic orange. There are different techniques that we could produce particulate system, and the selection of this technique will depend then on the final physical-chemical properties of the system, and of course the application, the finality of these particles. So encapsulation has several advantages when it's related to food applications. When we're talking about microalgae compounds, as I have mentioned, they are many of them are very unstable. And encapsulation with this coating layer, it's able then to protect from the adverse environmental and processing conditions, the bioactive. If you're talking about the baking or the frying, or even during the storage process. The bioactive then, the encapsulation then is able to maintain the biological, functional, and physical chemical property of the active agent, which will consequently increase the stability and extend the shelf life of a food product. Another advantage of encapsulation is to improve the solubility of a compound into a dissimilar medium. As I have mentioned, if we have a bioactive with a different polarity of the food matrix, we can make a layer that will be compatible with the food network. And another advantage is if we would like to incorporate small amounts of a bioactive in the food matrix, we could encapsulate to make it this process of the uniformity will be better. Another advantage is then the possibility of controlling and targeting the release of the bioactive as a response to external condition. For example, if we would like to protect the bioactive from the low pH of the stomach, we could encapsulate this bioactive to be released only in the intestine, for example. And this, of course, if we have this protection, we can enhance the bioavailability and bioactivity of this bioactive by sustaining sufficient time of gastric residence without degradation by the pH, low pH of the stomach. And with that, we have an appropriate gut permeability, which will lead to a suitable bioactivity, the expected bioactivity. And last but not least, encapsulation also are able to mask unpleasant flavor, which is particularly interesting for microalgae compounds that many times has this fishy odor that is not expected in a food product. All these advantages were already reported for microalgae compounds regarding food application, but most of the studies that it's found in the literature for the microalgae, for the microalga Hematococcus pluvialis and Arthrospida platensis. So then to conclude, I'm going to give this practical example, some results of the paper I published with some colleagues of my group to show then how encapsulation can really be beneficial for microalgae compounds related to food products. The name of the paper was entitled 3D Printed Functional Cookies Fortified with Arthrospida platensis, Evaluation of its Antioxidant Potential and Physicochemical Characterization. So the aim of this study was to fortify 3D printed cookies with the microalga A platensis, aiming to develop a new functional food with antioxidant properties. I'm not going to go deep in the 3D printing part here. I'm just going to focus on the physicochemical evaluation. The parameters were assessed 24 hours after baking and after 30 days of storage. And we evaluated the color, texture, antioxidant activity, and water activity. So the first step of this study was the extraction of the antioxidant compounds from A platensis. The extraction was done by ultrasound using hydroalcoholic solutions as solvent. The optimization of the extraction process was done by a design of experiment approach, and the effect of ethanol ethanol total solvent ratio and microalgae mass and volume of solvent ratio were evaluated. The response variables were total phenolic content as indicative of antioxidant activity, and total phenolic, ABTS and ORAC as antioxidant activities. The extraction was performed for 30 minutes and for 1 hour. Here, seeing then the response surfaces from the design of experiment, we can see here in graphics in the red part that the best condition was for the extraction was always using 2% of microalgae mass is the lowest amount of microalgae mass. Using the lowest amount of ethanol was 0% ethanol, which means 100% of water. So this condition was selected to extract the antioxidants from A platensis to be incorporated in a cookie dough. So the cookie dough was then prepared by 3 different approaches. The first one was the incorporation of 2% of A platensis biomass, the whole cell. The second approach was the direct incorporation of the freeze-dry highest antioxidant extract in the same amount found in the 2% of biomass. Here we have the specific blue color from phycocyanin, because we use 100% of water, and phycocyanin is a water-soluble protein. And a third approach was encapsulating this high antioxidant extract into alginate microbeads, aiming then to protect the extract from the environmental conditions during the storage and during the processing, during the baking of the cookies. Here we can see the cookies just after 3D printing. and here just after baking. And here was the 3D food printer used for printing the cookies. Regarding the encapsulation of the antioxidant extract, the technique used was wet quilling by vibration. Here we can see a picture of the equipment and a schematic drawing. The matrix was then sodium alginate with freeze-dry extract here in the needle. This matrix was going to pass in here through a nozzle, and under pressure, there was going to be a vibration under a certain frequency to form the droplets. So the droplets were going to fall down in the gelling solution, which is calcium chloride, to form then is going to be the hardening process to form the microbeads that we can see in the picture here. So regarding the physical-chemical characterization of the cookies, the first graph here, we have the ABTS antioxidant results. We can see that after 30 days of storage, there's no significant difference between all the formulations. On the other hand, for the ORAC antioxidant method, we can see that after 30 days, the encapsulated extract presented a higher antioxidant activity than all the other formulations. The difference between those two methods is related to the mechanism of action, while ABTS is more focused on measuring fast-acting antioxidants. ORAC, it measures more slow-action antioxidants. Here in the table, regarding the total color variation, we can see in the third column the values comparing the cookies just baked after 24 hours and after 30 days of storage. Values between 1 and 2, it means that only an experienced observer could see the difference between the color of the samples, and values between 2 and 3.5 means that any unexperienced observer could see the difference. So in the encapsulated extract present a value between 1 and 2, showing then the encapsulation promoted a color stability when compared to the other formulations. And regarding the texture analysis, the cookies were evaluated by the resistance to penetration or hardness, but it was shown that no significant difference over their storage time was found for all the formulation, which means that incorporating the biomass, the free extract, or the encapsulated extract doesn't change the texture of the cookies. And lastly, the water activity was evaluated, but all cookies presented values below 0.3, indicating then high microbiological stability of all formulations. And just some final remarks. The incorporation of the microalgae platensis as a natural ingredient resulted in 3D printed cookies with innovative appearance. The encapsulation of the antioxidant extract was capable to improve the antioxidant activity and the color stability along the storage time when compared to all formulations. And these results then reveal the potential of a platensis for the development of a functional 3D printable food ink, and showing them the benefits of one of the benefits that encapsulation can give, and we're going to apply to food products. Sorry. Thank you for listening. I cannot listen. Sorry.
I'm sorry. Thank you, Marta, for your presentation. It was very, very informative, and it was very clear. And well, do you think these cookies can break the barriers that make people avoiding to consume microalgae products?
I'm sorry, couldn't understand. Could you repeat, please?
Do you think that this cookie can break the barriers that make people avoid to consume microalgae products? Or
yeah, I can see a lot because 3D food printing is kind of a new technology. It's not something that we're going to right now to have in our houses, but I think it can happen in the future. So it will be interesting, for example, for kids, because they have these different colors, so we can make cookies in different 3D shapes. And that I have tried all the cookies and the taste is the same. This doesn't change just because you put the microalgae or the extract.
Yeah, yes, nice.
Yeah.
And we have another question. Did the encapsulation had an impact on the taste of the cookies?
No, that's what I try all of them. No.
Okay, because you haven't evaluated the organoleptic characteristics?
So, I mean, I didn't do the sensorial analysis, but I have tried, and then because the microbeads, it was 200 micrometers, don't think was enough to feel while eating the cookies.
Okay.
Besides.
Okay. And last one, which food ingredients do you have used with Arthrospira to make cookies?
Sorry?
Which food ingredients you have used with Arthrospira to make cookies?
Like the normal base, the control cookie, it was butter, sugar, milk. It's a normal, one thing that was very important, considering the 3D food printing, is that we use Shantangan, because it can help to keep the structure of during the 3D printing, so it can hold the layers. And this was just we just did a simple shape, but of course we could try to do something more elaborated, and then it's important that the structure remains. But it's a normal cookie recipe aside the Shantangan.
Okay, thank you so much, Marta.
Thank you.
Thank you. Okay, let's move on then to our next speaker, who is Laurent Picot, who is the professor assistant in biochemistry. Well, he's going to in the University of La Rochelle in France, and he's going to talk about microalgae pigments, their extraction and purification, and their applications. So, when you want, Laurent.
Thank you, Elizabeth. I'm sorry, I cannot share my screen. I need some technical trouble.
Sorry, Laurent?
I cannot share my screen.
Okay. Then, okay, maybe, I don't know, because maybe you can send the presentation.
Laurent, can you try again? We have just made you a co-host. Can you try again, please?
Yes. Okay. Oh, okay. All right.
No.
Okay.
No.
Is it okay now?
Yeah,
Yes.
we can see it.
Okay, perfect. Thanks. So I'm sorry about these technical problems. Maybe I will take a few minutes to show you after this presentation the stakeholder database. So I will speak about microalgae pigment, their structural property, and what we can do with them, and how to extract and purify them. So as we discussed, in fact, there is a large chemodiversity in microalgae, and cyanobacteria cannot be considered as microalgae because they are prokaryotic. So in fact, in microalgae, you have some eukaryotic species, you have some prokaryotic, which are cyanobacteria, and dinoflagellates are mesokaryotic. So there is really a large diversity of species with diverse and original pigments, and also a lot of interesting metabolites. And these species, they can adapt to a lot of diverse environment, you know, with a lot of sun, a lot of salt, and so on. And
sorry, Laurent. Sorry.
Yes.
Could you put the presentation in full screen, please? Because
it is for me.
It is not for us, I think. But well, if you can.
She means in presentation mode. It is full screen,
Yeah.
but in presentation mode.
It's not in full screen, Laurent. you hear me?
Yes, I can hear you. I'm trying to put it in a full screen for you.
Thank you.
Can you see it now?
No, it's still no.
Because it is in full screen for me too.
It's okay. If that's it, let's go on.
Okay.
Okay.
Yeah.
Okay. All right. All right.
Thank
So now until now, more than 200 pigments and derivatives have been highlighted in microalgae, and of course, this offers a lot of potential for industrial application using this pigment. So as it was also discussed before, pigments are a good way to add value to algae biomass, because producing algae biomass is not so expensive, but if you can extract some pigments, you can really add value and sell some very expensive compounds. And so in microalgae, you can find four types of pigments. The first one are chlorophylls and derivatives. So you can find them in all microalgae and cyanobacteria, and also you can find them in seaweeds. But microalgae offer a lot of advantages to produce much chlorophylls and derivatives. The second family of pigments is carotenoids, and these pigments are highly interesting, for example, for pharma application. The third one is the phycobiliproteins that you can find in red microalgae, in Rhodophyceae, and in cyanobacteria like spirulina. And the fourth one are polyphenols that were recently demonstrated in brown microalgae. So these pigments are not so studied, but they may have a high interest for develop cosmetics, for example, anti-UV pigments. So if you take one species, of course, you will find several pigments in this species, and this is like a kind of identity card of the species. It's a chemotaxonomic marker of the species. So, for example, if you take Tetracell mistioseca, it's a green species, and you will find some chlorophyll A, chlorophyll B, some xanthophylls, which are oxygenated carotenoids, and beta carotene. So you can.
So sorry, Dr. Laurent.
Yeah.
I'm not sure. I think it's because we cannot really see the slides. I think it would be better if maybe you can just exit full screen, and then you can move the slides manually. That way we can maybe see a bit more of the screen that you are.
Okay. Can you see the slide now?
Yeah, now we can see them moving. Yeah, I think that's going to be better.
All
If
right.
you could maybe reduce the zoom so that we can see more of the screen, like reduce the percentage of the screen to I don't know what, I cannot see what the percentage is of the zoom. If you can reduce it just slightly.
Try to. Can you see the slide now?
Yeah, we can see it. Yeah, we can see it, but it's just like a side of it.
You can try to press F5.
Okay.
Maybe.
Is it better?
No.
Can you see my slides? I don't understand why I have so many technical problems with that. Usually I don't have this kind of problem. Can you see my slides?
Yes.
We can see the slides.
Can you just go down below the sizing bar? There is something which shows the presentation mode. Just go below. Take your cursor below. Near the sizing bar.
Even it is in the top, the saving button, no, top. In that last button is.
Is it okay like this? No.
No.
Wow. So So I will give an overview of the main pigments now. So porphyrins, chlorophylls, and derivatives, they are porphyrin pigments, apolar to moderately polar. These are deep green pigments, and some polar derivatives are gray, and these are thermosensitive pigments, so they are damaged by heat when you extract them. And these are also photosensitive pigments. Extracting them is quite easy because you just have to make a soaking experiment in ethanol or in acetone, and you can use sonication or microwave assisted extraction to improve the extraction yield and purity. And you can also use some eco-friendly techniques like supercritical CO2. But purifying these chlorophylls and derivatives, you will need some chromatographic system like columns, silica columns, or flash chromatography, or CPC, which is a centrifugal partitioning chromatography. And chlorophyll and derivatives, they are used for food and cosmetic coloring, but their main high value application is to develop a tumor and antibacterial photosynthesizer that you can use for phototherapy. So these compounds, you can activate them with light, and you can induce the production of reactive oxygen species to kill bacteria or to kill tumor cells. And so the estimated price of chlorophyll A is about 200 euros per milligram. I mean the pharma grade chlorophyll A. And for the derivative thiophorbid-A, which is a demethylated and demethylated derivative, it's less expensive, but this compound is patented for as a photosynthesizer. Phycobiliproteins, these are found in rhodophytes and in cyanobacteria, and these are highly polar protein pigments containing linear tetrapyrrolic chromophores. And these pigments have a particularity, they are highly fluorescent. According to the species, you can find three main pigments: phycocyanin, which is blue, phycoerythrin, which is pink, and allophycocyanin, which is gray. These pigments are thermolabile, but you can use them, they are highly fluorescent. So they have a lot of application as fluorochromes, coupled to, for example, to antibodies for immunofluorescence or diagnosis and cell biology. If you can extract and purify some, for example, phycocyanin from spirulina, you can sell this like 20 euros to 100 euro per milligram of phycocyanin. So it's a very expensive compound, and depending on the grade, you can really sell a very high value compound. And extracting phycobiliproteins is quite easy because you just have to make a soaking experiment in water. But if you want to separate the three ones, you also have to develop some purification systems at industrial scales, just like chromatography on silica gel. The third kind of pigments are carotenoids, and these probably the most interesting pigments that you can find in microalgae. These are terpenic pigments that contain 30 to 50 carbon, and they are moderately polar to highly apolar, like beta-carotene. So I gave some example of pigments with industrial interest, like beta-carotene, astaxanthine, fucoxanthine, zeaxanthine. These pigments are thermosensitive, so they are damaged over 56 degrees, and they are photosensitive too. You can easily extract them using ethanol, acetone too, and also you can improve the extraction yield using sonication, microwave assisted extraction, and so on. And some industrial processes also deal with the precipitation of carotenoids. They are used as food and cosmetic colorants, antioxidants, they have anti-inflammatory activity. They have also a very interesting activity to limit the holding of the eye, so to limit to sustain eye health. And most interesting is that they have anti-cancer activity, pro-apoptotic activity in cancer cells. They limit metastasis, and they can be also used to prevent cancer. And we have shown in my team that they are also able to sensitize tumor cells to the effect of anti-cancer drugs. So they have a chemosensitizing activity. They are also used as photoprotective and for fragrance. Some carotenoid derivative have a very nice smell. So the estimated price of beta carotene is about 750 euros per kilogram if you have a highly purified beta carotene, and astaxanthin is about 2,500 euros per kilogram. Fucoxanthin, that you can see on this slide, is sold as an anti-obesity compound, and so many nutraceutical applications have been found for carotenoids. So now I will give a few information about how to extract and purify this pigment. When you want to purify at industrial scale, you have to think about how I'm going to extract this pigment. If possible, if I can use an eco-extraction a system that is good for the environment. And the main problem is to purify these pigments. Then you have to characterize the molecules, and you have to develop some relevant models to study pharmacological activity in cell culture, for example. And then you have to consider how to produce these compounds in high amounts, which is a limitation at the moment, and how to go to a marketing authorization for this compound. So at each step of this process, like for example for eco-extraction, you should consider all the how to improve this step. For example, you have to find a simple experiment to extract them and to purify them. You have to find a fast experiment, reproducible with high yield and a high selectivity to extract the pigment. And also you have to consider the cost of the extraction and how to produce these pigments at industrial scale. So if we want to make a conclusion about microalgae pigment, the positive points are that there is a very high chemical diversity of these pigments. Most microalgae pigments have no oral toxicity in humans, and they have a lot of interesting biological, pharmacological, and photophysical activities for food, feed, cosmetics, nutraceutical, and health application. Also, you can add value that allows a good valorization of algal biomass by biorefining pigments and purifying pigments. And now the biological and physical behavior of this pigment is very well known, so this allows to develop some efficient and high-yield extraction and purification processes. But on the other side, we have to say that there's a need to develop some extraction and purification processes, because only few pigments are purified at industrial scale. Many bioactive pigments are not sold in high amounts, and they have a very high cost, and they need a lot of energy to purify them. And also there are many experiments that show activities in vitro studies and animal studies, but only few pigments have obtained market authorization for human use. And in my opinion, we have to find some new innovative application for this pigment. Like, for example, using these pigments as chemosynthesizers to anti-cancer drugs, or to develop some new innovative photosynthesizers. So I added some interesting references if you want to have a look, and particularly for carotenoids, the Japanese database is of high interest. And I would like to thank you for your attention. If you have any question, I would be very glad to answer.
Thank you, Laurent, for your presentation. It was, and I'm sorry for the technical problems that we are having, but yeah, the presentations will yeah, will be sharing with you. So sorry, I have background noise. No, okay, yeah. And yeah, we have a couple of questions, Laurent. Can you hear me? Laurent?
I can hear you.
Okay, okay, now. And one of the first one is how much of the cost of those high value pigments are due to the production, extraction, or purification?
Sorry, can you repeat about the cost? That's it?
Laurent?
Yes?
Okay, how much of the cost of those high value pigments are due to the production or the extraction or the purification?
Okay. It mainly depends on which pigment. For chlorophyll, they are not really extracted and purified at industrial scale because they are not very used for food application. And extracting chlorophyll derivative is quite easy and not so expensive, you know. If you want to extract, for example, phycobilly proteins, extraction is quite easy, but purification is a big deal, and you have to use some columns with silica. And I know some companies purify with high yield and high purity some phycobilly proteins. For example, Green Sea in the south of France is able to purify this and make a lot of money with that. I don't have any idea of the cost to purify these phycobilly proteins, but the value is really interesting to sell this compound after that, because they are used for pharma application. And for carotenoids, it mostly depends. Well, astaxanthin, beta-carotene, and zeaxanthin are very easy to purify. And minor carotenoids like fucoxanthin and other minor carotenoids are not so used at industrial scale.
Okay. Okay, thank you. And another question is how big is the market for those high value pharmaceutical applications?
Well, for at the moment, what is known is, for example, for fucoxanthin. Fucoxanthin is a very interesting carotenoid because it has anti-cancer activity, anti-metastatic activity, and it is already sold as a nutraceutical, as anti-obesity compound. But the pharma market has not really I would say is not really developing this kind of compound at the moment. And in my opinion, there is a big market for it, because this compound can really be interesting for people who want to prevent cancer and so on. So my idea is that the market is really going to develop in the next years for carotenoids particularly.
Okay, thank you so much, Laurent, for your presentation and for your time. Okay.
Thank you.
We will continue with the last presentation. Well, it's not actually a presentation. Hi. Can you hear me?
Yes, we can hear you.
Oh, no. Okay. The last presentation is a video about a comic developed within the EnhanceMicroAlgae project, presented by its author, Julia Pison. Julia is an illustrator with some scientific background that allowed her to understand the microalgae world to be presented in the comic. So we will share the video with you.
Hola, soy Julia Pisón, la autora de Microalgas, El Mundo Oculto, el cómic realizado dentro del proyecto EnhanceMicroAlgae. Soy ilustradora y dibujante de cómics de A Coruña, Galicia, y voy a contaros cómo fue el proceso de hacer un cómic de divulgación sobre las microalgas. En 2017, José Manuel López Vilariño de la Universidad de La Coruña y Glecex se puso en contacto conmigo para hablarme de esta idea que tenía.
If you can play again, please.
Sorry, Claudia.
Yeah, we are not able to see the video, so if you can play again and share your screen, thank you.
I'm going to share my screen. Okay. No. Now?
There we are.
Okay, perfect.
Hola, soy Julia Pisón, la autora de Microalgas, El Mundo Oculto, el cómic realizado dentro del proyecto EnhanceMicroAlgae. Soy ilustradora y dibujante de cómics de A Coruña, Galicia, y voy a contaros cómo fue el proceso de hacer un cómic de divulgación sobre las microalgas. En 2017, José Manuel López Vilariño de la Universidad de La Coruña y Glecex se puso en contacto conmigo para hablarme de esta idea que tenía de hacer un cómic de superhéroes para hacer divulgación sobre las microalgas. En aquel momento yo tenía la idea de que las microalgas eran minúsculas bolas verdes, así que no sabía si estaba ante un loco o ante un visionario. Pero bueno, todo artista le interesa un gran reto de vez en cuando, así que empecé a leer la bibliografía y documentación científica que Vilariño me pasaba, intentando extraer datos sobre las propiedades de cada microalga y de cómo podrían traducirse en las características que definieran los personajes de la historia. Descubrí entonces que, por ejemplo, la espirulina no es una verdadera microalga y me pareció un interesante elemento de conflicto personal para el personaje de espirulina. O que las diatomeas son las microalgas más comunes y que por su importante papel en los distintos ecosistemas de la Tierra podrían ser pues, el Capitán América del mundo microalga. También fue clave, por ejemplo, la ayuda de Carlos Fuentes Brunewald de la Swansea University para definir las características de los distintos personajes y la dirección que finalmente tomaría la historia. Así que con toda la información que tenía de los distintos personajes, escribí una historia de aventuras en la que, al mismo tiempo que nosotros, los personajes se descubren a sí mismos y su valor en este planeta. Algunos de los referentes de esta historia son los Goonies, Érase una vez la vida, o cómics como Leñadoras o Albóndigas del espacio. El guión se traslada entonces al papel, empezando por un storyboard donde se planifican todas las páginas y los capítulos que tendrá el cómic. Y a partir de ahí, todo el proceso gráfico de dibujo de un cómic, el lápiz, la tinta, la rotulación de textos y bocadillos y el color. durante todo el proceso creativo el equipo de la UDC fue de gran importancia, ya que ellos se encargaban de la ciencia en el cómic. Por ejemplo, podéis ver cómo al principio crea espirulina de un color rojizo, una decisión meramente estética, pero en la revisión del color me informaron del importante pigmento verde azulado de la cianobacteria, así que cambiamos todo el color de nuestra heroína. Las separaciones entre capítulos se aprovecharon también para hablar más en profundidad de la ciencia detrás de la historia. Y el resultado final es, como podéis ver, este comic book de 56 páginas en el que vamos conociendo de una en una las distintas especies de microalgas encarnadas por 4 adolescentes con el potencial de salvar el mundo y de las distintas amenazas, que juntas van descubriendo su propio valor y su lugar en el mundo. Ha sido editado en inglés, español y gallego y próximamente saldrá en portugués y francés. Bueno, y si ya habéis leído el cómic, os preguntaréis qué pasa después del continuará, y estamos a punto de editar una segunda aventura de nuestras microalgas titulado Microalgas en el mar de Ardora, en el que veremos nuevos personajes, nuevos diseños de vestuarios y nuevos problemas que afrontar. Espero que os haya gustado este breve resumen de cómo se hace un cómic, y nada, también contaros que paralelamente hemos ido haciendo otras cosas, como crear un perfil de Instagram con tiras cómicas y viñetas sobre las microalgas, que se llama Microalgae Cartoon, en la que se admiten sugerencias y curiosidades para crear nuevos contenidos. Packs de stickers de WhatsApp y una agenda y calendario de mesa para el año 2020 que tenemos aquí. Como veis, crear un cómic y personajes atractivos es una fantástica forma de hacer divulgación. Para mí ha sido un gran placer participar en este viaje de investigación y creación. Incluso me he convertido en una experta en datos absurdos sobre microalgas. Así que nada, para cualquier pregunta que tengáis podéis encontrarme en mi cuenta de Instagram o en mi email, que dejo por aquí para que toméis nota. Un saludo.
Okay, hope you like the video. And again, if you have any question about this comic, don't hesitate to write directly to the author or type your question in the box chat, and we will send her your questions. Okay, can you hear me?
Okay, yeah, we can hear you.
Okay.
So I can see that a lot of people are asking about where they can get the comic book. It was a very interesting video. So you can find it on Amazon. It's particularly available in Spain. The people responsible for printing this comic book are in the University of A Coruña in Spain. They're gonna probably print a second edition for the second chapter of the book, but you can find the links of the comic book in our website as well. And I think the other languages will be available later. But if you have any question about this and how to get it, just email us or contact the author of the comic book, which is Julia. So I hope you like the video. This is very, very cool, this aspect of science communication for microalgae, at least for our project.
Okay.
So we're gonna move on to the final section of the webinar. This is basically like the closure. So we're gonna have 2 Q&A sessions. One directed for the EMA tools, if you have any particular questions about what you saw in the first session, and also something more related to the research and development outputs and uses of microalgae. So we have 2 sessions. So you're going to see a slide here showing you what to do to go to either one of these sessions. And you should also have received the details for the Zoom meeting. So if you're going to discuss about research and development, you can stay in this meeting. If you want to discuss about the EMA tools, then you go to the other session. And Costas is here as well. You want to say something?
Sure. Thank you, Gonzalo. First of all, I'd like to thank both of you, both Gonzalo and Elizabeth, for chairing the sessions and sharing the questions with all of us and trying to overcome various technical issues. But hopefully we made it till the end, and actually we made on time. So I'm hoping everyone is happy. We are going to ask, we've said throughout the webinar, make everything available, and that includes recordings and the presentations, even if they were not showing properly all the time, but most of them were, and then anyway, everything is going to be available on the website. We are going to send you information about that, just to remind you where this will be accessible. Also, further questions you might have had during the webinar, we're going to answer, and again, put them on the webinar site, on the project website. And also, we're going to forward a short survey, right, for you to get a little bit more information about your very kind participation. Okay? So thank you all very much for still being here. And I will see you in one of the 2 breakout sessions.
Okay, thank you.
Thank you.
Elizabeth, I understand that Costas will chair this session, research and development session.
Claudio, the idea was for Gonzalo and Elizabeth to be chairing the sessions anyway, but I'm going to be in session 1, and then maybe try to jump around a little bit in session 2 to see how things are. Yeah.
Okay, so I understand that we should keep in this.
Yeah, in the
all right. So group 2 is all right. Cool.
Yeah, in the research and development outputs. Yeah.
All right.
So group 2 is R&D, yes. Group 1. So you might be also in tools, right? Because the DST is
yeah.
So I mean the main idea was for speakers of session 1 to be in the session 1 breakout and speakers of session 2 to be in session 2 breakout. However, I mean,
it's up to you, basically.
Whatever you think is best. I mean, the original idea was for speakers of session 1 to be in the other room, and this
okay. All right. So I'm going to the other room. Okay.
Let's do that, and I'll go to the other room too, and then let's see how that works. Yeah.
Okay. Thank you.
Okay. Cool.
The thing is that we don't have many people in this group, I think.
Okay. I mean, you can all move to the other room, or you'll see. I mean, Elizabeth, you stay and chair this one, and if you think that the conversation is lagging, then you can all join the other room. Yeah.
Okay.
But for example, Laurent should be here and maybe have a chance to.
But I think Laurent is going to be in the tools also.
Okay.
Yeah.
Let me go there.
Can you see the screen with the groups?
You can see. So basically, Maria Jose, Laurent, Paula, and Gonzalo will be in group 1, and Costas, ourselves, and Martina, Elizabeth, and Marta will be in this one. I think we should keep.
Yeah, I think it's
like this. Okay.
Yeah.
Yeah, it's to balance both groups, I think.
Fine. No, that's good.
Okay. All right. So I don't know if we have questions from the audience in this group session. Right, group 2, research and development. So if you have any question, please.
I'm also going to say we're going to follow slightly different format. Actually, if you use the raise your hand functionality, you can actually ask your question live. We don't necessarily need to write in the chat box, although that's also an option. And then Elizabeth will facilitate that. But raise your hand, and then Elizabeth will give you the floor to ask your question. Yeah.
Okay.
All right.
Let's see. Because I don't know. Oh.
Let's see. How do we raise our hands virtually is a question. So there is
they can unmute their mic and just ask.
Yeah.
I mean, it's not that busy, so we can do it more informally.
Yeah. So please, to the audience, if you want to ask something to us.
Unmute yourself and maybe start your video or not, whatever you choose. Okay, I'll start asking a question just to warm up. Claudio, so the next version of the DST that you were mentioning about heterotrophic and mixotrophic, when do you think it's going to?
So the deadline that we have for that new tool is basically by the end of the summer. So technically, I would say in September we will have the new version of the DST, and basically, as I have said during the presentation, we will include heterotrophic cultivation and mixotrophic cultivation. So we will include some other parameter like carbon source and expand the parameter that we have, and the audience will be able to play either mixotrophic, autotrophic, or heterotrophic. So,
and maybe for the audience also, could you explain, is it standalone? Do they need any, I mean, what kind of computational?
No, so basically you will need a standard Microsoft Office, all right? It will depend on your version. If you have Windows 10, then you go for 64 bits, or if you have a oldest version, you go for 32 bits. And I had some couple of questions in the chat, and basically just to let you know to everyone, this is not to try to identify an algae, a microalgae. This is mainly to test your own algae. So the only parameter that you should know about your algae is the maximum growth rate, right? Using just that parameter, all the rest you can play with. So basically you can change the light path, the ammonium concentration, you can change the volume, and so on. So I would encourage to all the audience try to play with this tool, because it's a really good tool actually.
And also it's a good idea when you do that to send some feedback.
Yes.
Right?
Yeah, we are happy to basically to reply all the question, and actually this is one of the aim of the project, try to get more in contact and closer contact with the stakeholder and with the companies, with all the audience in the microalgae arena. So that's the main idea.
Very good.
Okay.
Any questions from the audience? I mean, we have a lot of people.
There are a lot of people.
I had one in chat.
Yeah, so we have one question, apparently.
Yes. Should I ask? Can everyone hear?
Yeah,
Go ahead.
Okay, great. A question for Claudio about the decision support tool. When you demonstrated it, it seemed that there were three options for each parameter. For example, like the light intensity was 200, 500, or 1000. Are these adjustable? Am I allowed to adjust this if I use it? And if not, then how come that it's limited to three options? Are these industry standards, or is it more customizable?
Yeah, basically, Ron, what happened that we ran like a 3 scenarios in that case, talking about just the ammonia concentration, and actually you can realize that we are using ammonium as a nitrogen source. So we can use a nitrate and so on, but this other nitrogen source have a different kinetics, right? So that is why we have choose just 3 options. A lower amount, a medium amount, and the standard amount or high amount, which is around 1000 micromole of ammonia. That is one of the, I would say, drawbacks, you know, but anyway, I was explaining to Costas, I don't know if you had heard that, but basically we're gonna launch a new version of this DST tool by the end of the summer, hopefully by September. And the idea is to include more options on that. So I'm gonna ask, I'm gonna speak with Kevin and try to include more nitrogen source option and more concentration, because technically you cannot. I mean, if you have the knowledge and go to PowerSim Pro and try to change those parameters, yeah, you can do it. But as a user, you can't do it. So basically, you have to those parameters, yes.
Okay, thank you.
Yeah, you're welcome.
Claudio, there's another question about if the tool can be used to simulate production in a batch reactor.
Yes, of course. So basically, what you can do in there using the tool. So basically, you have to set the amount of time that you cannot set the amount of time, but basically you say no background dilution, and then you have to do virtually no harvest, right? So you will see that at the very beginning of the curve as a kind of batch, right? Because the idea of this tool is to predict a constant and in a semi-continuous culture, right? So that is why we put harvest, all right? And every X day you can harvest, and those X day it will depend of the strain speed in terms of growth rate, all right? But you have to consider as a batch culture just the very first part of the curve. Later on you will see harvest, right? I can see here, instead of fixed values, can we see customized values? No, as I explained before, unfortunately, you have those values as a set mode, all right? So you cannot change that one. If you have the knowledge how to create a model, then you will be able to do that. But as I said before, in the new version that we're going to launch soon, by the end of the summer, September, actually, you will see that we will introduce more options in terms of light, in terms of nitrogen, and also some option for mixotrophic and heterotrophic cultivation.
Other questions?
Do we have more questions from the audience? No?
Not yet.
Not yet.
Anyway, I think it was great to have this webinar, and I think it's all the EnhanceMicroAlgae team have done a really good work, and I can feel that this project is really close to the companies and people. Huh? So they are every time they are visit our webpage, and they're using our tool, which is good, and that is the main idea of this project. Try to be more in contact with the real microalgae world, I would say.
We have another question, Claudio.
Mm-hmm.
The parameters will vary with the species, so how it will be adjusted?
No, and that is the way to use this DST tool. The idea is to, as I explained previously, the only parameter, biological parameter that you should know about your species is the maximum growth rate, right? As soon as you know the maximum growth rate, unfortunately, we have set values like 0.35, 0.69, and 139, right? You can put the closest to your strain. And then that is the idea of the tool, change different the other parameters. So changing volume, changing harvest frequency, change the ammonium concentration, the light path, the harvest, everything. So then you can play, and you will realize, for instance, what is the amount of biomass that you will get, what is the concentration of nitrogen that you will have in there, and so on. Okay, I have another one. Sorry, I missed initial part of the conference. What is the name of the tool? All right, so this is a tool that you will find in our webpage, EnhanceMicroAlgae.eu. Right, in that webpage, you will have in the taskbar, you will have you have to click on the basically decision support tool. We call decision support tool, DSTs. Yeah. My colleague in there, it's in the
Nick just said.
Yeah, so basically from that link you can download the ebook. I remind you that this is a live document. It's not finished yet, and it will be finished by the end of the summer with the model 2, right? And then you have to, what I would encourage you to read this book, right? Because it's a really, really good book. And then you can apply, you have to download the PowerSim Pro software, and then you can play with the software, actually.
So we have a question about future webinars. And so Abu says, it was wonderful to session. Now that we know EMA better, we want to see more technical sessions in the next webinar. And actually, the next one might not be a webinar, might be a live seminar, actually, which was the plan before the situation occurred, and it will be held in Manchester. So we're hoping early in the new year, if things return to normal, to hold an event in Manchester, and that will be actually, we'll have external speakers too, and it will focus a lot on technical development.
There's another question, but I don't know if it is for Marta.
That one is regarding the pigment. I think Laurent.
Yeah. Or Laurent, maybe.
Yeah, Laurent can reply to that one.
But Laurent is in the next room.
The other.
So Dr. Basumati, if you can go to the other room, you will find in there Dr. Laurent Picot, and he will reply you for sure, because he's one of the specialists in pigment. So I have a question from Marta. Marta, was a really nice presentation. So I would like to ask you, so it's quite, it's tricky to put that code on the cookies, and so it's really a kind of industrial scalable this?
Right now, I don't think 3D printing is in that level in market, but it could be because, of course, this device that we use was just for a lab scale, just one uso. Is very small batches that we could do in this situation. But of course, we can have bigger 3D printed with several nozzles. So yeah, it could be an industrial. But the main advantage, of course, is from 3D printing for food, is that we can do things on demand, personalized foods. So there's restaurants that could do some different things with of course, playing with the texture, playing with the shape. So not necessarily we can do that as an industrial way, but we can do to personalize something.
Okay, so perhaps the niche will be those kind of small specialized bakeries.
Yes.
Personalized.
There are some restaurants that
we know with your name on it in 3D with the I don't know Phycosine in blue. It would be interesting. Yeah.
Because it's not my area, my colleague at INL that is actually the specialist in 3D printing. But when I was writing the paper, of course, I was searching about the subject, and I have seen, for example, Barilla. They have printed different shapes of pasta that will normally won't be able, but as with 3D printing was, they could be done.
All right. Thank you, Marta.
Welcome. And I would like to just take and congratulate for the tool, because it's not my area, but I found very interesting.
Yeah, it was a question for you. Was it easy to follow the presentation? I mean, the tool specifically.
Yeah, totally. That's why I was. I don't understand nothing about microalgae cultivation, but was totally understandable, and it was very interesting.
Thank you. Okay, I don't know if we have more questions from the audience. If you want to speak, or if you want to highlight any kind of feedback on this webinar, or if you want to know something about the next step in our Enhanced Microalgae project, please feel free to ask.
Someone asked me about the presentation to send me through email, but are you going to make available in the website?
We're not going to send them to individual emails, but we are going to make them available through the website. Okay. So we'll make.
That's what I replied, just so I wanted to be sure.
We'll make a section for the webinar, and everything will be available. So.
Okay.
Yeah, so that is why I encourage the people who is following us now, try to get into our webpage in a regular basis, because we are updating the webpage kind of every week, and you can find news, you can find different, for instance, the DST tool is going to be uploaded again, the new version, and all other stakeholder, marketplace, all of that. So please feel free to come and join in our website. And
of course, the other way to get regular updates is to follow us on the different social media. There's Facebook, there's Twitter, there's
LinkedIn.
So LinkedIn. So if you follow us on that, we update them regularly. And then you know you're not missing anything. Okay, if there's no more questions, I mean, the nominal time has come, right? It's past 3:30 now. So unless there's any last minute. Okay, well, thank you for your comment, Kevin. He says it was a good seminar and he's glad to have hosted. So next one will be even better. And thank you all very much for staying that long. And we'll see you soon, hopefully.
Thank you very much, all.
Bye-bye.
Thank you.
Bye. Bye.